buy dry ice, I think, for about $1.50 a pound. And so a lot of these demos evolved out of last year because I could only buy I had to buy like an 8-pound chunk of it. Dry ice. So there's actually 2 demos here. One's called Boo Bubbles. It's kind of a fun thing you can do around Halloween for your. How many people have Ninos? Just that's 5 that weren't. All right. Well, anyway, for your kids, it's a fun thing you can do. Let's check that out. Good thing to do. Oh, I see you got it. George is a pro at this. So what we're doing is we're trapping carbon dioxide inside the bubbles, and it changes the properties of the bubble, so that you can see they're a little bit stronger. And if you hold them with your hand, it will destroy them typically. But if you have cloth, does anybody bring gloves? If you guys want to play with this, you can. If you want to come up, this is a safe demo. You can grab a blue bubble with a cloth glove. I'm going to try juggling them. You guys want to check these out? Had a lot of fun with these last year.
What's the blue solution?
It's just dishwashing liquid. Can't hold it up. Last year I did. Carbon dioxide is a little heavier than air. It likes to fall. Whoops. So maybe it's a weird word. Okay, yeah, you could demonstrate that, I guess, if you want. Okay, so this is a different experiment. If you guys want to try this, you guys can come up and do this. So we learned about density yesterday. And you know, density is the ratio of mass to volume. Some matter it's more tightly compressed. It has more material in a smaller amount of space. And things that are more dense will fall below. And the whole planet's that way. The heavier rock things are down below, and then the water and the air. And within those layers, you have things that are more and less dense. And the carbon dioxide, you can see it's more dense than air. It likes to sit on this level here. And so what she's going to do is blow air bubbles. Try the big side.
There is.
There isn't? There's more in there. Blow really gently. Okay, let me get some more dry. It's smelling too. There you go. So what you'll see is the bubbles will actually levitate, and what the deal is that the bubbles that she's blowing have air, which is actually less dense than the carbon dioxide. There you go. You see them levitating? So this part of the demo is called the dry ice terrarium. You can make one of these at home.
There you go.
And they'll just kind of hang there. You guys don't want to, I guess it's a bigger classroom, nobody wanted to play with the blue bubbles. Okay. I had a smaller class last time, but.
We have a volunteer. Drew, right? There you go. Everybody.
Looks like it's boiling. Is it hot?
You want to look at the blue bubbles? Yeah. Is that it?
I think we probably need hotter water to get the hose going. I could get some more hot water.
Do you want me to grab some of those?
Probably need electric. I don't know if the dry ice will last.
You want me to blow bubbles?
But we'll see. Try to get it like boiling again. Oh, there's a little more hot water left. Okay. It's just hot water and dry ice and dish soap. I think there's not enough dry ice, so it's the properties of the bubble have changed, and they're not holding up as well. If you hold it up a little bit, you usually get a better. You're getting air somehow. There we go.
Anybody else? Thank you, guys.
There's another demo. You want to do another demo? Sure. If nobody else wants to come up. This is to show, there's different gases we breathe around us. A lot of times we don't think about them because they're invisible. But since we've isolated the carbon dioxide gas, if you just want to gently lower it into the terrarium, and
Right out.
yeah, hey, that's pretty good. You did it perfectly. Okay.
Just one.
So when you have a fire, you're taking something like methane or something, burning with oxygen and producing carbon dioxide and water. These reactions, I know this is all kind of, we haven't talked a lot about all this. It's kind of jargonistic stuff, but there's combination of elements and they have different properties and they can undergo reactions. And this is a classical type of reaction called combustion reaction. And so it turns out that if we add one of the products, if we add the CO2, the reaction goes backwards and it ends the reaction. And so that's what you're seeing with the candle flame.